Okay, we are looking at the data for Lab 6, which is aerobic capacity. If you open up to page 43, you can read the intro there. Flip to page 44, it gives a procedure that we went through as Sam did the maximal treadmill VO2 test. And then what I'd like to talk to you about is page 45 and the metabolic results. So as you look at page 45, you also need to be looking at the test results that are scanned in as well. When you look at the test results, we're going to work through minute 1 for number 1, number 2, number 3, and number 5. Turns out you can't do number 4 until you've completed all the minutes for all the other calculations. So we'll talk about that in just a minute as well. So let's look at number 1. Number 1, we're calculating the volume of inspired air. So VI equals VE at STPD times 1 minus FeO2 minus FeCO2 over 0.7904. So the VE at STPD, if you look at your data sheet for time 1 minute and 2 seconds, VE equals 47.94 liters per minute. 47.94 liters per minute. And if you look at FeO2, FeO2 is also listed for minute 1. It's 16.12, but that's a percentage, so you need to move your decimal point over to your left a couple spaces to get rid of that percentage. So it's going to be 0.1612, and you'll see that on my data sheet in the calculations. And then FeCO2 is also a percentage, so that's going to end up being 0.0445, and then 0.7904 is given. So we have all the variables we need to calculate for VI. If you work through that calculation, you'll see exactly how I did that on the data sheet. You end up with 48.18 liters per minute of inspired air. The next calculation is absolute VO2. If you look just to the right there, FiO2 is given at 0.2093. So FiO2 is 0.2093. VO2 in liters per minute equals VI times FiO2 minus VE times FeO2. Working through that calculation. We just calculated for VI, which is 48.18 liters per minute. FiO2 is given, which is 0.2093. And just so you know, in ambient air, about 20% of the air that we breathe in is oxygen. So that's what that means. So 48.18 times 0.2093 minus VE is given on our data sheet, 47.94 liters per minute. Multiply that by FeO2, or fraction of expired oxygen, is 0.1612, and that's also on our data sheet. So work through that calculation. You'll see that on the data sheet that I scanned in, and you end up with 2.35 liters per minute of VO2 for calculation number 2. Number 3, we need to calculate relative VO2. So that's going to be pretty straightforward. Take the liters per minute of VO2, divide it by Sam's mass, or weight, which is 77.3 kilograms, and then multiply that number by 1,000 to convert into milliliters. After you work through that equation, you're going to get 30.400 milliliters per kilogram per minute for minute 1 relative VO2. Number 4, it says percentage of VO2 max equals the VO2 for the period, each minute is 1 period, over the max VO2. So the issue there is we have to calculate number 2, or absolute VO2, for every minute. So minute 1, 2, 3, 4, 5, and 6, you're not going to use the last one, which is 704. So you're going to use minute 1, 2, 3, 4, 5, 6, and 7, 701. And you're going to calculate VO2 and VI for all of those before you can calculate the percentage of VO2 max. So once you get a percentage of VO2 max, you're going to take a VO2 for the period and divide it by the max VO2 that was found. So you're going to have whatever the highest VO2 that was found is going to be your max VO2 you're going to use for that calculation. Number 5, calculate RER. RER is VCO2 over VO2 for each time period. So for minute 1, VCO2 is given in our data sheet, and it is 2.12. And we calculated our VO2 up in number 2, we got 2.35 liters per minute. So very simply, we're just going to take 2.12 liters per minute, divide that by 2.35 liters per minute, and the RER for minute 1 is 0.902. So you are going to have to go through and do those calculations for each of the 7 minutes that Sam's test lasted. So you're going to have 7 calculation number 1, 7 calculation number 2s, 7 calculation number 3s, 7 calculation number 4s, and 7 calculation number 5s. Then you're going to end up putting that in a data table that you will get into me. But you'll need to do all those calculations. You can do them by hand. You'll need to scan them in and send them to me so I can see you did those calculations. And make sure you email me if you have any questions.